And we're live. Welcome back to another Corona Geek here where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever. And today we're going to continue our conversation. We've been discussing putting together a game using Gravity. It's all about Gravity, really. And if you missed the first two sessions, you need to go back and watch those because they kind of lay the groundwork for what the game is about and how the Gravity works and all that kind of stuff. And also Ed has continued to modify and update the code as we go along. So there's links in the show notes for that as well. But it's all based on the premise of they need to be fed 3. I don't know if you guys have seen that, but it's a pretty fun game, and there's some interesting mechanics that are there. So we're going to head into that today. Joining us on the panel is Dr. Brian Burton down in Abilene. You can find more of his stuff over at burtonsmediagroup.com. Also joining us is Ed Marina from roaminggamer.com.
Hey.
We've got Greg Pugh from gpanimations.com. And we've got Kevin from Seaburn Games. And we've also got Stephen Johnson from ibabastudios.com. And Hans, do you have a studio name?
No, not at the moment.
Okay, so Hans is joining us for the first time. As is anyone welcome to join the panel at any time and come and hang out. And so let's go ahead and get into it. Ed, did you have? Oh, before I start, actually, or before we start, does anybody have any announcements? I know some of us haven't been here in a while and things like that. And any news?
Nothing really. Released a few things last week, but I put them out in the forums. You know, I can't even at this moment remember what they were. A couple of utilities and whatnot. SSK updates, some stuff like that. I posted it all out in the forums. Guess it wasn't that exciting because I can't even remember what it was.
So go check that out, I guess.
It's good stuff. It's just I'm so focused right now on.
Yeah, that's cool. The forums are a good place to hang out. I know Alex does the from the forums every week, and he tries to pick out highlight some nuggets. But there's lots of great stuff that happens in there all the time. So I'd say if you're not accustomed to going to the forums, go in and find a conversation that you are interested in, and mark it so that you get updates, and then you'll be notified anytime somebody says something. It's a great way to stay connected. Stephen, I know you said that there is the Lua, what was the Lua conference?
Yeah, it's in Stockholm. So if anybody's over there, I think it's in October. I'd have to check when it is, but
it's October 15th, and I know Roberto, the chief architect of Lua, he's going to be one of the keynote speakers or whatnot. So that would be.
There are a lot of Corona users in Sweden and Finland and that surrounding area. So I'm sure that'll be an excellent conference.
Yeah. This is. I know that Stephen, as you pointed out, Sergey has gone to these in the past couple of years in Russia. So yeah, if you're in Stockholm or in the neighborhood, definitely check it out. We'll put a link in the show notes. You can check out the whole schedule. It's as I understand it from Sergey, it's a great session to go to. Lots of great, in-depth sessions. Look at Lua and the inner workings and things like that. So definitely want to go. Anybody else? Any other announcements?
Yeah, let me say something real quick. I've gotten a lot of emails in the last few weeks asking about updates to the textbooks, and they are still free. If you've purchased any of the textbooks through my website before, then you can get all of the updates for free. If you purchase through Apple or Amazon or Google or one of those places, I don't have any control over their pushing out updates or being able to download the latest version. But if you are interested, you can go to burtonsmedia.com, go to books, and then book update, and you can get the latest version of any of the textbooks you've previously purchased. So that's just in response to a number of emails I've gotten in the last couple of days about classes starting up and wanting to get the latest version of the books.
Do you highlight that anywhere on your website that if they order directly from you, they get updates?
I think I do. I think it's mentioned it's mentioned on each of the book pages that updates are free.
Well, I was just wondering, to differentiate, maybe say going to Amazon or going to one of these other sources, just to sweeten the pot, that when they order from you, they get this extra
You
bitty.
know, I probably need to make that more clear than
Spell it out.
what I have in the past. That, you know, if you get it from me, you get the free updates. The other companies I have no control over. So
Right.
I'd love to have control over Amazon or Google or Apple, but it just hasn't happened yet.
Yeah, I doubt that they're going to give you that level of control.
Probably
But hey, if you guys are on the fence about training materials, definitely check out burtonsmediagroup.com. We've said it before. I'll say it again. Dr. Burton pushes out these updates to these books, and they go out. Like you said, you can go and get your update for the book. And what other book seller does that? What other publisher does that? Nobody does that, right? So you get advanced copies before books come out. You get updates after the books come out. There's no additional charge. It's really amazing. So yeah, I think you need to seriously toot your own horn.
Yeah.
Just toot your own horn, like on a
my own horn a little more.
yeah, I care about you, and here's what you get. I mean, just kind of like spell it out, because it's people are so busy, and it wasn't until just this moment when you said, getting it through Amazon or getting it through Apple, that you don't have control over those to be able to push out updates. And I'm like, oh, that kind of stinks.
All of them, I contact them whenever I do push out an update, but it's completely at their discretion and their timeline when and if they'll push the update out to people.
Right. Interesting. Okay. Well, cool. burtonsmediagroup.com. Check it out.
Hey, I forgot to mention one thing, and then I'll launch into my game dev thing here. Besides the things that I just mentioned, the answer packs came out last week, and some utilities. I did offer a new service, and I'm having some other things coming up, as Charles knows. But one of the things that I'm offering now is hire a hitman. I thought that'd be a good, get the government interested. But basically, it's a service that I'm going to be offering for people who have tried to get help in the forums and they didn't get the help that they wanted, or they need a little bit more one-on-one time. And so it's a pay-as-you-go kind of service. Actually, you send me your hit details, I tell you what the hit level will be, and then we take care of the problem. Everything, of course, is framed in the hitman nomenclature there.
Right.
So at the very least, you should go read the page, because it might be entertaining.
Okay.
I'm trying to get my stupid devices to stop dinging. You probably hear them in the background, but I apologize for that.
Well, cool. I think that's good, having a focused conversation on the things that people want help with, right? I mean, that's just getting right down to. I mean, because sometimes that's all we need. I don't know if you've seen. Was it AirPair? Is that the service? I'll have to find it. But anyway, there's a service out there that's kind of along these lines that you're working on a project and all you really need is someone to get you over the hump, right? I don't want you to write it. I don't want you to write it for me. I just want to figure out, like, Kevin was talking before about, how Facebook's so hard to deal with, or some aspect of Twitter integration, or whatever, right? And that. In those moments, someone who's done that can just say, "Oh yeah, you just click here, go there, do this," and makes life so much easier for you. Here's the link: airpair.com. I'm not saying that you should go there to circumvent Ed's system. I'm just saying, Ed, you might consider that. They call it micro consulting.
Another link for me to follow up on.
Yeah,
here.
exactly. I'm just here to give you stuff to do, Ed.
Okay, good. Yeah, okay, I think I got all my devices to be quiet now, so I can actually talk about what we're going to be doing today. So let me jump.
Well, sweet. Let's jump into it, because I'm super excited about this topic.
All right. So can you guys see my screen?
Yes.
Okay, good. So last week we left off with basically I talked about it briefly, but I didn't show you the code for animations, new art, pretty art. Jumping and air control. I also talked about briefly how to pair up the keyboard with the simulator so you could use it instead of having to click on the screen when you're testing, so because you don't have multi-touch, and I'm waving at the screen like you can see me. You don't have multi-touch. Yeah, I do that all the time. So what I really need is a camera, picture-in-picture here, so people can see me waving with my hands and emphasizing. But you don't have multi-touch in the simulator, but you oftentimes need to be able to touch components in your screen, your interface that are far apart. Like, for example, I wanted to touch these buttons, but then jump, and then come back over here and test air control. And it was too much work. I mean, I couldn't just like zipping back and forth with my mouse. So I said, okay, forget it. We'll just hook up those key events and use the keyboard. So that was the tip from probably the number one takeaway tip from last week. Okay, was that me? I'm sure I turned these things. Okay, my devices are going insane over here.
Yeah,
I'm
it
just
must be.
gonna put them under the desk.
It's just you and me, and I know it's not me.
Oh, nuts. It's very annoying. It's like the thing won't shut up.
Yeah, I feel the same way. I've got Windows phones over here and Android tablets and all this other stuff, and there's times where, like, when an Amber Alert goes off, it's like, whoa, what the hell?
Yeah, exactly. It's like, I can't get my devices to just stop making noises when I'm talking. All right. Okay, so this week, now we're getting into the really fun stuff for me. I mean, yeah, all of this has been great. We talked about how to do gravity. We talked about air control. But I've been telling people, sort of pushing off and saying, hey, there's this thing for creating levels and blah, blah, blah. And that's about as much as I described it. And I said, but don't touch it yet, because I may change it. Well, I'm done changing it. And now we're at the point where we can really start kind of just like adding new stuff and create new types of level elements and coins and pickups and spikes and stuff like that. And so today we're going to talk entirely about the level loader, and we'll talk a little bit about the builders. Now the builders, just to be clear, are the little bits of code that will build the elements on the screen, like the monster or the coin or the round platform or the square platform. So I've already gone through this once, but just briefly, the layout of the project is a traditional layout. It's a little bit hard to see here, but you've got your build settings, config, main. You've got a few other files in here. RGCC is the Roaming Gamer collision calculator, because I don't want to calculate up my own. I don't want to do the math, so I just use a piece of code to calculate the okay, that's definitely not me.
It's okay. Yeah, just
The filters. To calculate up the filter settings for collisions. So that's what I use this for. An icon, because I like to have some kind of icon for these things when I build them. And SSK, which is just being brought along. That's my library, being brought along for the ride to give me things like left and right and some predefined functions that I like to use all the time, like dumping out tables. And then an images folder, where you're going to find all the pretty images under a folder called Kenny. So we got the coin and the various level elements here. And the animations, I didn't show you that. And then a data folder, and that contains the level definitions, which we'll be talking about today. The files that we care most about today will be main, common, game. Let me make these a little bit bigger so we can see them. Level loader, and then some level file definitions that are under the level, under the data folder. So let's just walk through it really quick. We have main Lua. So it's got some stuff at the top for getting rid of the status bar, turning on multi-touch when we're actually on a device. We load up SSK to get all the goodness. Load up the Roaming Gamer calculator, which we're going to use, collision calculator, which we're going to use later. We load the common script, which contains, it's just a module. It contains all kinds of settings for our game. And we start physics, set gravity to 0, because we're going to provide our own gravity, which we talked about previously. And then we simply load the game script and start or create level 1. So if we go into the game script, yes, see, the thing is, okay, move on to the next file. So whenever I hear that, I'm going to move on to the next file. So in the game script, basically, it's another module, and it uses the physics library. It requires common, because we're going to use some variables out of there. It includes the inputs script, which we talked about on show 1, which basically builds up the, let me find it, builds up the buttons, and handles dispatching the events into the ether, so to speak, for the other objects to listen for. So just on that point, I like to do all of my game designs and pretty much most of my app designs in a way where the objects that are being touched will produce an event that gets thrown out for all the other objects that are in existence to listen for, so that I don't have to have my code connected. So the input code doesn't have to know about the player code, and the player code doesn't really need to know about the input code. All it needs to do is be listening for a runtime event of a certain name and then do something with the data that is attached to that event. So I see Charles. He's scrunching up his face a little bit there. Doesn't remember this episode. But this is my...
I'm
okay.
fine.
Okay, good. I'm watching Charles's camera here. That's good. I should watch my own so I know what's going on. All right, so the big bit here is you see a list at the top of Game Lua, and there's a table called Builders, and then in this table, basically what I do is I create a field called Player, Round, Square, and in each one of these, I will store the return value of the require. So I call the require function, and I tell it to load the builder script for the player, the builder script for round, and as we see, I'm definitely not moving on to the next file yet. Although maybe, yeah, that's a good point. Let's do that right now.
I think you know what I think that is. I think that's a chat or something in the background.
Yeah, it could be.
It's probably you probably have a window open someplace that has a chat on it.
Yeah, either I've got a window open where somebody's trying to chat me, or something. I turn all those things off, but they come back on. So
it's the mystery for the day.
And well, I'm getting a lot of dinging because the show is on, so I'm almost sure that this it's some new thing that they're trying to help us with, where it's hooked up to Google Plus, and I'm getting dings on one of my email clients or something.
Mm.
All right, so scripts. Let's see. I'm sorry. Builders. So just to show you what this is, I'm going to show you the coins builder. So here in game, I've got builders.coins equal to, and then I require the builders, the coins builder. And this file itself is yet another module. They all follow this format where I say load the common scripts at the top, take that return value, and then I have a reference to it. Create a table, just a generic table called builder. And then on builder, I add a create function that takes some arguments, and then I return builder. So what I can do with that is later I could say, if I wanted to, builders, coins, create, and pass some arguments in there, whatever they may be, and that would call the function in this module, coins. Now the reason I did that is because what I wanted to do was put together a very simple way for developing and laying out the levels, which we're going to look at in just a moment. Absolutely driving me batty. Just give me 1 second here.
Trying to hunt down that strange dinging.
Yeah. Well, I got like half a dozen windows open here. Could be anywhere. All right, we're just going to have to live with it. All right, at least it's not pistachios. All right. So, carrying on. We're loading the builder modules, and we're putting them in a table, so we have an easy way to look them up. Still in Game Lua, I have some variables here where I store the rendering layers. We talked about that in episode 1 of this series. So 153, I believe. We have a table, although it's right now just a variable called pieces. Later on we'll put a table in here where we store all of the references to basically the round pieces and square pieces, which are our platforms in this level or in this game. And I have a variable that I've added recently called current level that keeps track of the current level that we have loaded. We're going to start with level 1. This demo that I will commit today at the end of the show has 2 levels. Then I forward declare two functions, one called reload on reload level and the other one called on next level. On reload level, the job of this function is basically to reload the current level and start over. And on next level is basically it will calculate what the current level is, add 1 to it, and if that is not higher than the maximum levels we have, it will load that level. So for example, the first time this was called, it'll go from current level 1 to current level 2, and then it'll reload, it'll just restart the game on level 2. But if it were 3 and our maximum level is 2, then it will go back around to 1 and it'll just loop around. So our logic right now is very simple. We just go level 1, level 2, level 3 until we run out of levels, and then we go back to 1. So that'll change over time, but this is our first pass on level loading. I localize some variables that I use a lot, random, get timer, and pairs. And finally we get into the create. So we've looked at this before. In create, the first thing I do is call destroy on the assumption that I'm going to call this again in the future, and I want to destroy the previous level that was loaded. So the first time you run this, it's not going to do anything useful, but after that it will always destroy all of the content in a game, and then we will rebuild it. Layers, we talked about this just a moment ago. I use a distinctive layering system and organization. I think I'm probably not alone in this, but basically I like to have one variable called layer, or layers, that contains references to all of the display groups that I'm going to be using, and then I can basically store those groups in a field on the parent group, and then I insert those child groups into the parent group to get this layering. So display current stage is the top level group created by Corona, and it contains layers, which is not shown in this hierarchy, and then under layers is underlay, content, and overlay, where underlay is at the bottom, content is in the middle, and overlay is on top of everything else. And so by having this very simple structure, I can insert content into any of these groups and know that it will either be above or below other content. For example, the underlay, I would insert typically a background image that I didn't want to move around, and then if I inserted items into content, they will always be in front of that background image, which is an underlay. And similarly, overlay I use typically for interface things like labels and buttons and things that must be on top of everything else. Alright, as in episode 1, this bit of the code hasn't changed. I created a blue background which I put into underlay, so it's always going to be underneath everything else. And then 4, which we're going to come back to in just a moment, I build the level. So all of the magic happens in these few lines of code. Of course, there are many more lines of code that are called because of this, but the basic structure of this is very simple and easy to follow. But moving on, just before we come back, 5, I create the inputs, the buttons, by calling the create function on the inputs module. And then 6, 7, and 8, 6 and 7 are basically, I created some indicators here. I created a coin counter and a level indicator that will be updated by our code to show us how many coins we've picked up and what level we are currently on. 8 is me tracking what current level we're on. So whenever this function gets called, the file level variable current level is set to level num, which is passed in the create function right here, which we called from main. So for example, if I put in 2 in main just to test it, I reloaded this, our level indicator would show 2, and current level, the file level visible variable, would have 2 in it, which is important. Go ahead.
I've noticed in your projects that you tend to do that from like a speed of development or speed of testing. You tend to do things like that, like being able to turn off the initial splash screen, or being able to turn off the initial menu and be able to get right into the game, or be able to jump.
I'm a big fan of things that speed up development and prototyping, and having flags for turning on and off features so that I can sort of like minimize the problem set that I'm trying. Usually what will happen is I'm doing development and I run into a bug or something. And if you leave everything turned on, then you could have a real problem debugging. But if you know that I've got the debug code turned on, but I don't have any of the fancy animation code, or I've turned off, for example, if I went into Common and I said don't load the dangers and don't load the others, I was trying to track down some problem that had to do with, say, gravity or something, then I know that these things are not interacting because they're not even being loaded. So I think that's what you were talking to.
Yeah. I think those are good things to take note of, and good tips, because I think, at least for myself, I know when I start down the road of looking at a project, I'm like, okay, well, I'm just trying to solve the question of how do I make these things do this into a whole game, right? So you don't look at it from a perspective of I want to be able to turn these things on and off, because that's really not.
Yeah, that's not. It actually,
part of the game.
In a sense, it makes it more complicated because you've got to think ahead.
Right.
But once you get into the practice of having the ability to enable or disable parts of your game, you'll find that it's very useful for developing and debugging. Another thing is sometimes when you're developing a game, like this one is pretty simple. It started out really simple. It was just squares and circles and squares and circles. But it started to kind of get more and more stuff on it now. So if I only want to deal with debugging and coding that one bit, having the ability to turn off all the other parts really helps simplify the problem at hand.
Yeah, I know. I'm thinking specifically right now. Kevin's on the panel, and he's got a game that he's working on. It's got 60 different levels to it. So I'm thinking it would be good to be able to jump into level 59, like from the beginning.
Yeah. Right. Yeah. Oh, I'm sorry. You were pointing that out too. Yes, exactly. I always have cheat entry points so that I can go to any specific level or part of a level that I want to debug. I've got zero patience for having to play my own games to test features that are somewhere off in another part of a level, or like this one's really simple. It's a very small level, but you can imagine a game that's very broad, very tall, like some kind of a platformer. For example, I developed Side Topic, a game a few months back that was an endless runner style game where it got progressively harder as you went along, and more enemy elements came in and obstacles and stuff. And there was no way I was going to play it out to level 60 to test the level 60 elements every time.
Yeah.
So I could just crank it up to level 59 and then play up into level 60 and say, okay, yeah, that's working. At least I feel fairly confident that that transition worked and that the element pieces that I thought should be there are there. I mean, there's always other things that can go wrong, but yeah, for anybody listening, don't play your games all the way through every time. I mean, it's good once or twice, but if you're trying to get it done sometime this year, you need shortcuts into sublevels and etc.
It's like a video editing. If you have a piece of music that you're going to use in your video, you always save it to last, because otherwise you're going to hate that piece of music by the time you're done editing everything.
Absolutely, and that's also why I have these debug features in here where we started off with just circles and squares, because I didn't care about animations and I didn't care about having the right color or something like that. I just wanted to make sure the basics worked. So start simple, add complexity only after you're sure that the game fundamentals are working. Because if you add all the complex, I see a lot of new developers do this. They go in and they go, oh, it'd be really cool to have this animation, the particle effects, and they get all these like cool-looking things, and they get all caught up in that. But the core part of their game either isn't any fun or it doesn't work. So, and I'm sure we've all seen that with people asking questions in the forums, where they'll get way ahead of their knowledge level and comfort level with the code, and get stuck because they got sidetracked by something else.
Yeah.
So speaking of sidetrack, see how I did that?
Nice segue.
So what are we doing? So today is levels, all about levels, and I just want to run you through the overview of the concept first. So in game Lua, back on line 84-ish, we have this section, and what it does is this line here loads up a script whose job it is to translate our level files into meaningful information that the builders can use. And I'll explain what that means in a moment. So level loader is basically more like a translator, but I called it level loader just because it seemed reasonable to call it that. So level data is a variable that will contain the information in one of these level files. And so, well, it'll contain the translated information from one of these level files. So levels itself will translate the contents and return a long table that can then be used by this loop and the builders to do the work. So just forget about this for a moment and pretend that level data now has the translated level information. I'll walk you through how that works. But the translated level information, it's all prepped and ready to go. And basically what we do is the first step here is we create a blank table. I talked about this at the top called pieces. So I put a table in pieces. And again, pieces, the job of that table is to contain the circles and squares here. And it doesn't contain the coins, it doesn't contain the player, it doesn't contain the spikes. It only contains the objects that we care about as gravity sources, which we talked about in episodes 1 and 2. Another piece of the code here in this game will iterate over pieces every frame, and it will say, is the player near to it? Yes, it's 100 pixels away. Is the player near to it? No, it's 200 pixels away. And it finds the one that it is closest to, and then it does some fancy calculations to apply a force between the player and the nearest gravity object. So again, pieces only contains basically our platforms, these silver bits here that we see on the screen. However, the builders, I decided to create them all with a uniform signature. So when you say signature, what you're talking about is basically the arguments that the function takes. So all of the builders take 3 arguments, but not all of the builders use the arguments that are passed. For example, the coin builder doesn't use the pieces table. So you can pass it in, but it just ignores it. So this loop basically iterates over level data, which is just a numerically ordered table. And I'll show you what it looks like in a minute, so it's not too confusing. And it takes each subtable. So this is basically a table that contains a series of tables, and each of those individual subtables is a definition that says this is a circle platform, or this is a spike that goes at the bottom, or a spike that goes at the right, or it's a coin and it goes at the bottom. Those details. So we take it and I do a little shorthand notation where I take the current one we're looking at, I assign it to data, which is just a local variable inside the loop to make my coding a little simpler. I could have not done that, but every place where data is, then I would have to do this and that. And I'm a lazy typer, a lazy programmer, honestly. So typically when I am digging deep into a table and extracting one element, I will take that element and put it in a local variable inside my loop, and then use that to reference any fields or values in the table. It's a little bit quicker execution-wise, and it's easier for me to type it and understand what's going on. So extract the current element we're looking at, put it in data, and then determine which builder goes with that. Now I know it's a little bit probably confusing, but in a moment when we look at these individual elements, you'll see that they all have a field called type, and type will be something like square or circle or coins. And if you remember, at the top of Game Lua, we set up this builders table with fields called player, round, square, coins, etc. These are the builder types. So our level table has a bunch of subtables, and each subtable has a field called type. Type refers to the builder script that is supposed to do the work, which lets us look up the create function for that one. So round create, square create. Hopefully this is coming clear for folks. I won't do it at this point, but I'll show you what these tables look like, and maybe it'll become more clear. So we've identified the builder, and I temporarily store a reference to that builder here in my builder variable. And then I simply say builder create. So I reach into the module that I've selected by its type, and I call its create function, and I pass in the layers. I pass in all the information for this particular piece, because the builders themselves still need to look at that record and say, oh, is it rotated to the right? Is this a spike that goes on the top? I mean, we don't know very much about it. What's the position that it's at, X and Y? All of that stuff is stored in this record. And then we pass in pieces for those builders that use it. So now, before we look at any builder code, let's take a look at how we lay out a level so that this all starts to become clear. So the final organization that I have settled on, I could have approached this in a few different ways. I could have created a visual editor where you could drag and drop, and I did that on a previous episode for another game. But I thought that in this case, because we're going to be working with a game where all the elements are on a fixed grid, they can only be at certain positions, that it would be easier to simply create text files, in a sense, that contain these level layouts. So the levels for all of the levels in this game are stored in an individual file, level 1, level 2, etc., etc. And within these files, it's a typical copyright statement and some comments at the top. But the interesting bit is we create a table in this file called level. Could have called it anything. Empty table. And then in this table, I create 3 subtables. I create a subtable and I store it under platforms. In this table right here, under platforms, I create another one called dangers, which is spikes and other things. And then I create another one called other, which is the coins and the monsters, because the monsters, although it sounds like a danger, they are actually our goal. We want to get to the monster, so they are sort of like the others table here is designed to contain pickups and all the good parts of the game. Platforms is just what it sounds like. It's the circles and the squares and the bits that we're supposed to jump on. And it also contains a marker for where to put the player at the beginning, to put the player for that level. And then dangers is all the other bad bits that we don't want to touch. So if we look at these files, I decided when I did this game, and you could change this later, I decided to make, let me find it, I decided to make the levels 8 by 8 grids. So they're 8 across, 8 down. 64 locations where a platform could be. I could have made this anything I wanted, but in the interest of legibility and tractability, the ability to understand what I'm talking about and showing you, I wanted something that I could easily display while we were talking. So what I've got here is a platform of tables where if there's 1, 2, 3, 4, 5, 6, 7, and 8 across, but I just laid it out like this so I could read it. Then I have a comma, and it goes down to the next line, 8 across, and there's 8 columns and 8 rows. But really, when this gets loaded, this is one big long table with 64 entries. So at some point, although it looks nice here, I did this so that I could sort of, in my mind, say, oh, this is the upper left corner, this is the lower right corner. This is row 2, column 6, and this is row 3, column 1. So this is purely laid out so that we can look at it and say, okay, this is where our guy starts, there's going to be a round one here, and load it. Here, our guy starts and there's a round one here. No, I wanted that to be a square. Okay, Squares are S. Okay, so we put an S and we reload it, and now we've got a square. So this visual representation corresponds to the way I laid it out in the file.
What does the number stand for?
Okay, you're jumping ahead, but the number, okay, I'll tell you. So I ran into this issue. Basically, what I wanted to do was have one builder, for example, for the coins, where I could use that builder to create a coin, but then I needed some easy way to encode the position of that coin. So I can have one coin per block, and I can say the coin will be on the top, it'll be on the right, bottom, or left. The top is 1, the right is 2, the bottom is 3, and the left is 4. So for example, the example we had there, if I wanted the coin, let's find other, coin, you'll notice that this is 1, 2, 3, 4, 5, row 5, column 3 is the square, this bit right here. So 1, 2, 3, 4, 5, row 5, column 3 is where I'm going to put the coin. So just to be clear, this layout is these things are exactly in the same position in each of their individual tables. So if I want a coin and I want to move this coin to the top, I would put a coin in this. I'd put a coin marker in the other table at the same position as that block, but I would change it to C1 because 1 is the position for the coin at the top. Now I'm going to have to show you this code so it makes sense. Now when I load it, the coin is at the top. So basically, I knew that for certain elements in my game, I would want to position things in a certain way. And I wanted to keep the signatures consistent. So every signature is 3 characters, where it's a letter, an underbar, and then a number. If there's not supposed to be anything there, it's just 3 underbars. 3 underbars. So, and I'll show how that gets decoded in just a moment.
Okay. So, but basically, anybody watching this could say, "Oh, I see the concept of what he's doing," and then they could create their own system.
Yeah. This is there's a million ways to create levels, but what I wanted to create was for this discussion something that was very straightforward. You could look at it and go, okay, I know that S1 is in this position, and I know X is a spike. Okay, so the spike is going to be in the same position as the square, and it's going to be on side 3, which is 1, 2, 3. 3 is on the bottom. Okay, that's what I wanted. No, wait. I wanted to put the spikes on the left, so let's make that X4. Save it, reload it, and now the spikes are on the left. Very simple. People can go in here and quickly copy these and play with them. Not even have to know how the code works. That's the beauty of this, is once the code is in place, all you got to do is lay out these files, and you're done with the level creation. That means nothing more you need to know. However, at this point, people are like, I don't know how it works, and I do need to know. So let's take a look at this. Level loader. So level loader, as you recall, was called from this portion of our code. So we require the level loader, and then we call this function get, and we pass it the number of the current level that we're trying to load. Now the level loader, its job is to read these tables and to turn them into useful information that can be used by the builders. So let's take a look at how that works. So if we open up level loader and we look on line 46, we'll see the beginning of the function get. It takes a number, level num. First thing it does is it creates a blank table called level. Could have called it anything. And then it defines some functions here. Let me just review here quickly. Right, so I generate 2 functions. One called convert to level records, and another one called finalize level. And then if I skip past that for just a moment, below that basically I run convert to level record and I load the platforms subtable. So I require data.level, which is, let me find the file here. What that statement is saying is it says look in the data folder, find a file that starts with level, but then we append the level number, so it's basically a require to data level 1 or level 2. So that'd be the same as if I typed like level 2. The standard require statement. So what I'm doing here, just to be clear, is I'm dynamically in the code telling it which file to require, and it's going to load that file. Now it may have already been previously loaded into memory, but if not, it'll actually go out onto the quote-unquote disk, read it, and then return whatever is in that file, if it returns something, as an argument to this function. So at this point, this will return, if we were on level number 1, it would return this table right here, which has 3 subtables. And then, I take that value, that return value, and I extract just the dangers table, or just the platforms table, which then for level 1 means that it would pull out just this part right here, this table that we defined, and extracts that, and then it passes it into the function that I'm calling. Yes. Okay, ding means people understand. Great. So again, level loader get takes a variable called level num, which contains a number. I take that and I append it using the dot dot to a string called data.level, which turns this into a valid file name, data level 1, data level 2, etc. I then pass that string, that new string that was just generated, into the require function, standard Lua function. That will load the module. The module is going to be level 1 or level 2 in this case, because those are the only levels that we have. So it assembles all the stuff just like we looked at, and then it passes back a table containing subtables. We then take that table and pull off just one of the subtables by using the dot notation. So in this case, I want the platforms subtable. So that whole bit of code right there gets replaced with the contents of this table right here.
And I see this is how you are turning off dangers and turning them on according to what you want in the commons file, right?
Yeah, exactly. So as you can see here, there's a variable called load dangers and load others, which is in the common. And if these are false, then this line here doesn't execute, or this line here doesn't execute. But I always load the platforms. That's the base minimum for this game.
It took me a moment. I was like, why is he loading that line? But then he's conditionally loading these other lines, and then I was like, oh, well, you need the platforms to even have a game. So okay.
So I'm going to skip over this one bit for now, but convert to level records. The function that we defined above, we're going to look at it in just a moment. It does this special calculation. For the platforms, you'll recall that there's a special marker that says where the player starts. Now, we're using a camera that tracks the player, but for the camera to be in the right place and the player to be in the right place when the level loads, because we can put our player anywhere, we need to keep track of where the player was. So we can sort of like shift the world to where the player is when we start. We're not going to talk too much about this today, but because I need, in essence, to shift the world around, I need to know where that player is. So convert to level record looks for that specific marker for the player, and if it finds it, it will return an X and a Y value for the position of the player. So just for now, you can forget about this, but if people are reading this and they're saying, why does this one have center row, center column, but the other ones don't? It's because the platform subtable will have a marker in it that defines the position of the player, And that is supposed to be the center of our world. Everything else revolves, in a sense, around that center. And because we don't know where that's going to be in advance, we need to calculate it when it happens, or figure it out when it happens, and extract it. So that's what that does. Then, as you noted, we have the load dangers flag and the load other flag. And these two statements are exactly the same. Basically what they do is they convert those records into useful information. Got a little lost there, sorry. They basically extract the dangers table or the other table, and then they process them. So let's take a look in a moment at how this works. The only other step here is after we've converted these sort of not interesting, just three markers into useful data, then we have to take that converted data and actually build our level, or finalize that table. Really what finalize level is doing is each of these at this point, when this gets done being called, the relative position is unknown yet for each platform. We know their relative, but we don't know their absolute position. So it takes the center row and the center column, and it says, okay, now I know where the player is. Now I need to adjust how far away from the player each of these elements is. So in other words, it's looking at this data. It knows that this is row 1, column 1, and this is row 2, column 2, etc. But it doesn't know where the player is yet. So it just says, okay, that's row 1, column 1. But until I know where the player is, I'm not going to assign an x and a y value. But once I know that the player is at, let's say, row 5, column 5, then I can make this the correct distance away from that. It's a way of calculating positions. Perhaps this will become more clear when I run through the code.
But it's all relative to the position of the player. Okay.
Yeah, this is the key. The key concept here is that everything is relative to the player's position. So it's just an easy way. It was an easy way for me to set this up to make the camera code easy to write.
Okay.
It's not something actually that when people are digging through this, they need to think too much about. I would rather that people who look at this be concerned more with the concept of using individual builders to do work and understanding a simplified way of laying out a level. And if they can grok that, then the one additional level of complexity here, no pun intended, of understanding the premise of having a center position for the world, that's icing. But if they don't quite get that, it's still, if they can pull the rest of the lesson out, it's good. So let's look at the convert to level record, and then I'll show you what these things look like. In fact, let's go back up here to line 50, where I defined this function. Function's job is to basically take whatever subtable I pass in and convert it into something useful. So let's see what it looks like when I first look at the input content. So input is a table, and this function here, table print r, comes from SSK. It's added by SSK to the table library, and what it does is it prints out a nicely formatted listing that shows you a table and how it's laid out and everything that's in it. So when I run this, let me bring up and I finally learned how to make these things legible so that people can hopefully read this console output here. When I run this, print R basically prints out these tables, entry by entry. So entry 1, underbar, 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 etc., 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 and C1. So this one is obviously printing out this table right here. And as you can see, this comes out as a big, long, flat list that goes from 1 to 64 entries. So we still have to sort of like turn that into rows and columns. So let's start with that. I'm not going to go too deep into this. People can pretty much figure this out. But what I do is I have some variables here where I say I'm starting at row 1, column 1. Then I have a marker where I assume that the center of the world is at row 1, column 1 for now, because I don't know what it is. And if for some reason I'm like goofing around and I don't put a player definition in, I still want this to work. So in this case, I took the player out. But because it assumes that 1 is the center of the world, this is actually probably not going to look good. Yeah, that doesn't look good. So 1 is the center of the world, but there's no objects there. So let's go put an object at 1, just to make this a little more clear. So let's put a square marker there. This is the center of our world, and let's put another one down here, just so you can kind of see that's going. Now we should have a line of square markers that go down diagonally, and we'll be able to see 2 or 3 of them.
So before the pieces were there, they were just off the screen. We couldn't see them.
Yeah, the pieces were there, but because this camera was centered on this one, you couldn't see them. So now we got one here, we got one that's diagonally down, and we got no player, so I can't move around. But you can assume that there's more going down and way down off the right, off the screen. So again, the reason that's occurring is because in the level loader, I put in some code, and I assumed that, for now, the center of the world is at 1, 1, because I don't want this to break if I'm messing around and I don't put the player in. So let's put the player back. Everything goes back to normal.
I think it's interesting you chose B for player.
Well, B for begin. I could have put P for player too. You're right. I wasn't really thinking about the nomenclature at that time.
Gotcha.
I was just trying to get non-overlapping. Originally it was S for start, but then I needed S for square, so I'm like, okay, I need another thing that means start.
Okay.
Begin, B.
It's your
Good,
system,
done.
man. It's your system. It's okay. So, you know.
You could call it anything, though. That's the beauty of this. It's easy to change. Okay, so far, row 1, column 1. We're assuming that the center of the world is center row 1, center column 1. Now we basically loop over input, which you'll remember is a flat list with 64 entries, and each entry is a table that contains a 3-letter character in it. So it's basically, actually, I take it back. Each entry is a string, not a table, which is just 3 letters. So we need to turn 3 letters into a useful record or some kind of information that will later let us build that object. So what do? The first thing we do is I take and I put the one we're looking at, and I put it in a variable called entry. And then I use a function called split. Now split does not exist in the standard library, but if you don't want to use SSK and you want a split function, you can find one online. I extracted my split function from an online Lua some site that they had a bunch of Lua samples and solutions. But split is nothing more than a function which has been added to the string library. And what it does is it looks at a string entry, and then it says, let me find this symbol, and I'm going to treat that like a marker that I will separate the string. So, for example, if we were looking at this one, it would say, I found the marker, and what I'm going to do is I'm going to return this part, I'm going to return table, and this is going to be entry 1, and this is going to be entry 2. And if for some reason I did this, then the table would have 1, 2, 3, 4, 5 entries. Entry 1 would be S, entry 2 would be 1, 3, 4, and 6, etc. Basically, it's just a nice function to take a string that has some unknown token until you pass it into split, but you use some token, and then you can separate the elements of that string into sub-elements in a table. So then we can iterate over the table and get the first part and the second part. So this level loader thing basically is designed to have 2 parts. The first part identifies the builder, and the second part identifies any special positioning rules, like, for example, the coins or the spikes, where 1 is on the top, 2 is on the right. what I needed was some way to put that into a very easy to encode string and yet later separate it out. So that's what I've done. I have a string, I use this as a token, and then I return entry that then has basically a table. I've converted entry from a string into a table. So the return value of this gets assigned to entry, the string that was in there gets wiped out, and now it contains a table. And if we looked at that, it would look like this. So now you can see that the tables have two entries. One is a token that tells me what the builder is, and the other one is the special positioning rules. But the question you may have in your mind is what about these entries that don't have any markers? They're just 3 underbars. What does that do? Well, I have a function called dump, also from SSK, also extracted from somebody's external code, which I then modified a little bit for my own purposes. And its job is to print the contents of a single table, just the first level. And so if I dump out the resulting ones that have nothing and the resulting ones that have something, we're going to see this. So these here that say entry 1 equals and then it's nothing, that was one of the ones that had basically 3 underbars. So that basically is saying, when I look at this, I know that that means that it's empty. There's nothing in it. So I take this split out table, and then I look at it. I look at entry 1, and if it's a blank string, I know that that was an entry that did nothing. It was an empty blank space on my level. So I ignore it. Let's turn off the dumping thing again. But if it is not empty, if there's something in there, then I'm going to look at entry 1, and I'm going to look for the special marker that is for the player, or the begin marker, and I'll do something special. And what that special thing is I will say, oh, what's my current row and column? That's the real center row and column, which I'll return later. However, if the marker is not B, I don't do this. In each case, if the marker is not empty, I will create a table where I say type, and then I do a lookup, and I'll show you where this is in a minute, based on this value. Subtype, which is entry 2, so this is going to be 1, 2, 3, or 4. And then currently it stores the column as the X and the Y as the row. Because you remember earlier I said on the first pass everything's relative. We don't know the real position of everything in the world. So the best I know right now is that this is a row. I'm sorry, the X is going to be a column value and the Y is going to be a row. But I don't know what those really mean in terms of X and Y positions. I just know this could be like, say, column 2 and row 3. And that's good enough for now. So I'm going to store that information in the table. And what I didn't say is up here I created a local variable called record. And then in record, I create this table. So let's take a look at this bit right here. Let me just load the file again. At the top of this file, I have a table called builder files. And in here, I've done this same kind of like lookup thing. So I create a entry under B that says look for the start file. If it's R, the name of the file is round. And if this is unclear, let's take a look here. In our builders folder, we have coins, monster, player, round, spikes, and square. So this right here is basically giving me a way to convert that one-letter symbol into the name of the builder file that I'm going to use later to do the building. So when we look at these entries, that's going to be square, that will be the player, square, this will be spikes, coins, and monster.
So I have a question for you.
Go ahead.
You used the underbar as a token, you said, to separate the values in the string.
Yes, I use that as a token to separate the values in the string. This will be, and then the function that splits that will return a table with 2 entries.
Right. No, hold on. So I get all that, but my question, I guess, is was there an unstated reason for using a token to separate the 2 values, or could you have just smashed them together as an X4 or C1 or an M3?
I could have, but then I would have had no easy way to extract. I could have used substring then. String.sub, another function in the string library. But I prefer to use splitting because I know that later on I might decide to add more details. Like I might expand this to 3 elements, where say I can't even type here. X4Y, why Y has some special significance in my Uber game. Well, everything keeps functioning, and I don't have to go string sub 1 2 2 3 3 4. Oh, I goofed up. So that bit of code, no matter how much I expand this later, will always produce a table that can a sequence of tokens.
Excellent. Okay.
So it's just a way that I think, and so I chose to do it that way. But yeah, people could have in fact used substring, the substring capability of the string library, in which case they would not have needed the special split function which they get out of SSK or they can get off the web.
Okay, I thought maybe there was an unstated benefit there that I just wanted to kind of call out.
Nope. Okay, so we got this record, and the only thing that's left to do is check to see if a record got created, and not always will there be one. So we create a variable, doesn't have anything in it. If it's a blank entry, we do nothing, so this stays blank, has nil. But if it is not blank, we create a record with a type, a subtype, and a relative x and y position, which is just the column and row at this point. We take that record and we put it in our table, which we created at the top, right here, and we just say current entry +1, because it's going to be numerically indexed, and we store the record in it. And then when we get done with that, we have, let me find it, sorry. We have this. Not that. So I'm using the table dumping function again, which is going to print out a nice look at our code, or what's in this table. So now when we run this, this is what we get. We get this table that has a bunch of subtables in it. Why is the dumping still on? Oh, I'm using dump, sorry, not printar. So each one of these looks like this now. So we converted these into tables that look like this. We got a type, coins, monster, player. We got a subtype, 1, 2, 3, 4, or nothing if nothing was specified. And we've got well, these have been already converted into X and Y positions, but if I can't turn that bit off. If I had looked at this a little earlier, these would have like 1 or 5 or 6, just rows and columns in them. Let me find it again. So at this point, we got a level file that's got most of the information we need. Well, not a level file, but a level table. So the only bit that we have to do now is we have to go finalize that. The bit where we, now knowing where the player's X and Y position is, we can position the rest of the world relative to that location. So what we do here in this, originally I had all this code separated out, so you see these comments pass 1, pass 2, pass 3. Well, pass 1 happens multiple times now. So for each of the sub tables, other platforms, dangers, pass 1 occurs. But pass 2 and pass 3 only happen once. So the nomenclature is a little bit messed up here because I didn't change the comments. So if people read this, don't be confused. So pass 1 can happen multiple times, but in finalized level, we're only going to call this one time. And pass 2 is to go back over that level table that we had, that we created from doing all the other calls. And basically, given that we know where the player is, we do a calculation, and I'm not going to go into it. You can just look at it. It's basically multiply the row or column by a certain amount and add it to this row or column, and that's where the object is. So in a nutshell, if I said that the player is here, and this is column, the next column over, this column is nothing more than a certain distance away from the player, or a certain distance to the left. It's just an offset calculation based on the rows and columns that are stored in those variables, multiplied by fixed values, which is the size of the gap, and then we add that to the center of the screen, and we subtract the offset of the player. It's kind of goofy looking, but this maps out everything. I know I'm kind of, it's because we're kind of running over here, and this, I don't know how other to describe this.
This is just the distance between blocks, is that what we're saying?
Yeah, basically you've got a fixed distance between the blocks. So if you know that the player is at row 1, column 1, and you're trying to calculate the position of a row 2 block, then you know that you just take the position of the player, which is always in the center of the screen, and you add a certain amount to get the row or the column offset. And what is that certain amount? It's nothing more than the difference between the player's row and column and the row and column that you're currently at.
And that makes sense because you're dynamically laying out the level based on the information that's in the level file. Then you're centering on the player themselves, and so you want the player to be able to jump from block to block without being caught in a lurch. So you space the gaps out in a way that you know that they'll be able to make it from block to block.
That's exactly it. Remember how I said I could have made this like a visual editor? Well, I realized when I was getting ready to make that decision that because the gaps between the blocks have to be the same all the time, it's a fixed grid. And so knowing that this is a fixed grid, it creates this situation where I can easily calculate where every block is relative to every other block. It's always going to be a fixed distance. So if I create a way to convert a table 1 through 64 into some other kind of table containing relative information about the rows and columns, I can then calculate the positions knowing the relative rows and columns and the size of the gaps between rows and columns.
So I have a question for you, and
Okay.
this is a little bit like interrogating Jack Nicklaus and Jack Nicklaus or Nicholson. Which one's the golf player? Which one's the actor? In A Few Good Men, you know, when he's like they're up there interrogating him, and he's like, "Don't question the manner in which I give you protection." Blah, blah. Anyway,
Okay. So shoot me.
so my question is, if it's a fixed grid, 8 by 8, 64, whatever. I mean, could you have just
Laid them out in the same position all the time?
yeah, and then just turn them on and off?
Yes, I could. If I had done that, however, I would still need to know where the player is. Why?
Yeah.
Because the camera code, the code that moves everything around, has to know where the player is because it's following the player.
Right.
So then I could have done that. It would have been a little bit simpler. Everything else would have been exactly the same, except this little bit wouldn't have been necessary. I'd have been able to encode that directly right here when I did this step. But then I would still have needed to know where the player was, and I would have had to encode that in the camera code. And because I'm lazy, I like simple camera code. My camera code is like 15 lines of code. It's really super simple. Maybe 20 lines.
Gotcha.
So it's
But
if I hadn't done that, it would have been, I would have had to write code and then explain to people, I'm doing an offset and I need to wait 1 frame and then I got to do this thing. And no, forget about that. I'm not going to do that.
Well, and I think this goes back to the way that you usually put things together. You put things together in a modular fashion so that they're reusable.
Right, exactly. See, my camera code in this is actually reused from, what was that game with the hallways? Zigzag Boom Clone. Yeah, it's exactly the same camera code as that. So I didn't want to rewrite that bit. In fact, I didn't even want to talk about it. I just wanted people to use it.
So the question that I just asked would require hard coding a grid, which would only be good for one game, not for a library of games. Or
Exactly. See, this is much more universal.
yeah.
It's just that I got to think a little bit harder on this one bit. But once I get past that, I never have to think about this again. The finalizing was probably like the hardest part of this whole calculation. I'm like, okay, I know how that works in practice, but I still got to go do the calculation. So if you had seen me developing this, you'd see me going, nope, no, dummy, you forgot. You got to add half a distance. Oh, no, wait. No, it's not half a distance. It's subtract. Oh, wait, how does that go again?
I think you should live stream those sessions.
I should. You know, some people do that. In fact, it's funny you say that, but I saw a game. I was looking at itch.io from our talk on After Dark,
Mm-hmm.
and you guys have got to stop pointing me at these things, but I was looking at one of the games, and this guy is live streaming the entire development of his game, and he's been doing it for months, and he has a huge following. It's like, wow. What's that streaming service for games nowadays?
Twitch?
Twitch. It could be Twitch, yeah. I don't know. Anyway, he's live streaming his game development. I'm like, really? That's going to be kind of boring. Because I know that I get up and walk away, and people are like, where'd he go?
I heard that there are people that they like to watch live streams of people eating because they don't want to eat by themselves.
Yeah. There's some kid who's got like 75,000. He makes like $1,500 a day. People watching him watch TV and eat food.
Yeah. Well, people are lonely. They just don't want to be lonely.
I need that job, right? I can do that. That's a job I am highly qualified for. Watching TV and eating food.
There you go.
At $1,500 a day, I'm on it. Okay, so we're really kind of done with this discussion. I mean, there is more to it, but
here's
the summary is...
It's a cliffhanger. You just have to come back for the next week.
Yeah, I didn't get to show people the builders, and we have to do that next week. But the summary, the learning from this week is we took a flat list that was basically formatted in a way that was nice and easy to read, and then we created a number of these lists or tables, and we were able to take that, do some magic conversion, processing, and then we passed that process data into a function which we have not talked about yet, the builders. And then we get this nice layout, and it makes it very, very easy for us to say, I'd really like to have the spikes on the bottom. So that is a 3, save the file, reload. Oh, I think I have the thing selected. Oh, man, just shooting myself. Sorry. And I didn't do that. Rewind.
That's how it happens when we do things on the fly.
No, this never works. What's going on here? Do I have this thing selected? Just for people watching, if you select the console, here's a good one. You're editing and you do something silly like this and you try to reload, Windows says, can't do it. It basically, selecting the console locks the simulator. So if you get into this thing where you're trying to reload your level and nothing happens, then...
It might be a little bit of that.
Oh, you know what? S is not spike. X is spike. See, I can't even remember my own symbols. So I want that to be on the right side. Save it. It's on the right side. The point here is really easy, super easy to read. Once you got this laid out, you never have to think about the code again. You can just go in and super rapidly edit these levels, lay them out, and then play to your heart's content.
All right. So on. With session 1, we looked at the overview of the game, what the mechanics were going to be, and we talked about gravity. In session 2, we talked about air control and key inputs. Today, we've looked at the level loader, or putting all of the pieces in place and being able to design a level, basically. And then next time we're going to look at the builders, the pieces that actually load up all the characters, the spikes, the monsters, all that kind of stuff.
People are going to be very, very disappointed because the builders are really super simple pieces of code.
Is there anything else that we'll look at? The builders. We'll look at the builders, and then what else?
No. Okay. So once we've looked at the builders, the big question we'll also look at next week is level reloading and next level loading, just to see how that works. It's very simple. And then we will talk about checkpoints, which don't exist in this release. checkpoints come next week. And checkpoints, for those who don't know, is just basically a way to save your position within the file or within the level. So if you die partway through, you don't start at the beginning of the level. You start where you died or where you last checkpointed. So there'll be little markers, like in the original game, that when you run and touch them, they'll get a little marker. They'll change their what they look like, and you say, aha! If I die, I'm going to go back there. So it's a technique to keep your game from being too frustrating. If you've got complex levels and you don't want people to feel like, oh man, I got all the way through and I died, then I got to start over again.
So in this particular game, where you're avoiding the spikes, collecting the coins, and then you said we're supposed to run to the monsters, not away from the monsters?
Yeah, you're supposed to go feed the monsters
yourself.
In the original game, you're not picking up coins, you're picking up like gems or something, and the monsters need gems.
And in the original game, you're climbing up to the.
In the third one, the animation is you go up and you climb up into the mouth of the monster.
Yeah.
But in the first one, people will recall in the first episode of this 3-part sequence so far, I said I'm actually using elements from all 3 games. The problem is you can't get the first 2 games anymore. You can only look at them on YouTube. They were smart in that way, in that they said, okay, we've gotten our money out of number 1 and number 2. It's time for number 3 to be released, so we're going to remove those from the market, and we're going to go on to 3.
Really? So would you release? Would you remove 1 and 2?
Yeah, well, I think it's because they said, okay, we've satisfied. We got everybody who's going to buy our game has bought our game, and instead of giving them a level 2 experience, which is kind of like we were good, but we weren't as good as we are now. We're going to give them everything that was in 2, but more and better. And we don't want them buying 2 and thinking, it's an okay game. We want them buying 3 and saying, this game is awesome.
See, that'd almost be like, in my mind, if I had season 1 and 2 and 3 of House of Cards on Netflix, and I've only watched season 3, right? Because all my friends are talking about season 3, then I'm going to go back and binge watch season 1 and 2.
Okay, but that's not exactly the same thing. I would argue that maybe they get better from season to season.
Yeah.
I think my argument still stands, though, is that They Must Be Fed 1 was a basic implementation of these features. Less artsy, a little bit less artsy, didn't have all the mechanics. Then They Must Be Fed 2 came along, and then they added a whole bunch more mechanics. Their art got nicer and juicier. And then 3 was like the icing. And I think that what you would see is if you were able to side-by-side compare all of them, you'd go, wait. 3 and 2 are almost exactly the same.
So you wouldn't go back and play the old school pixelated
We would, because we're game developers. We would as game developers, and game aficionados would, but average consumers would feel like, hey, why did I just pay another $2.99 or whatever the game costs when 3 is very much like 2. I mean, there's lots of differences, but maybe as an unsophisticated gameplay, they'd go like, hey, this doesn't feel like it's worth another $3.
Gotcha. So it's the HD version of the game.
Yeah, I mean, I wish I could get their input. I'm kind of putting words into their mouth, but I'm guessing. This is me guessing at their motivation for doing what they did.
Okay. Yeah, I'm just thinking of the compounding effects of marketing, but okay. Yeah, that makes sense. I see
the compounding effects are still there because people still talk about and have their games.
Right.
It's just you can't get them anymore. It's like, oh no, you can only get the best and the most recent one.
Right.
So go get it.
Interesting. Yeah, before they take it off the store.
Yeah. Prices, I think, were different.
Do the Flappy Bird thing and threaten to take it off the store, and then.
I said, I would love to hear all of their motivation because I'm sure it's not quite that simple.
Right.
They probably really wrangled with the idea of whether to remove these things from the store or not.
Okay. Well, hey, I haven't had a chance to tell you about this yet, but Rob Allison is going to join us next week for he's going to talk a little bit about Laser Dog Games, what they're up to. They've got a new game called Hapiko that I don't know if you guys have seen this thing, but it's fantastic. Maybe we'll clone it. No.
Yeah, let's clone whole people. I'm sure that'll make them really happy.
That'll make it really happy. And they're also doing some great stuff with desktops, so we're going to talk to them about that as well. So,
well, that'll be a good fit then, because my topics won't take up. I can do this talk in half an hour. We can leave checkpoints for another day.
Okay, good. Good. That'll work out. All right. Well, you guys join us next Monday at 12 p.m. Pacific to talk about that. And also check the show notes for links to the code and go watch those previous episodes as well where we talked about gravity, key inputs, air control, all that kind of stuff. So, all right. Until then, have a great week and happy coding.
Woo!